Now we're going to use some calculus with polar equations. So the first thing we need to do is figure out how we get the slope of a tangent line of a polar equation, or in other words, take the derivative of a polar equation. Okay, so one thing is that polar equations are if we have a polar equation that's written in terms of r equals f of theta, so in terms the radius is equal to an equation in terms of theta, we can write our polar equation parametrically. So using the equation for the x component and then the equation for the y component. Okay, so I am gonna just do this on if x is equal to r times cosine theta, okay, and y is equal to r times sine theta, which, we see this in our coordinate plane. R is equal to, x is equal to r cosine theta, and y is equal to r sine theta. Okay, so what we can do is take the derivative of x, so dx d theta is equal to, and because this equation is written in terms of r and theta, we have to apply the product rule. So we have lefty right. So the left is r. Cosine theta's derivative would be sine theta, but negative. Plus right, which is cosine theta, times the derivative of r, which is dr d theta. Okay, now we're going to take the derivative of y with respect to theta. So we get left is r times cosine theta plus right is sine theta times left derivative of the left. So dr d theta, since it's implicit differentiation here. All right, so we can write the derivative of a polar equation as dy over dx, or in other words, dy over d theta over dx d theta. So this looks like dy is r cosine theta plus sine theta dr d theta. So r times cosine of theta plus sine theta dr d theta. And then dx is negative r sine theta plus cosine theta dr d theta. Okay. All right. You can memorize this rule, or you can always derive it by using the product rule. Okay. So what we're going to do is take the equation r is equal to 3 plus 2 sine theta, and we're going to evaluate the slope at pi over 6. All right, so we need to figure out what dy, okay, actually, I want dy dx, which is comprised of r cosine theta plus sine theta dr d theta over negative r sine theta plus cosine theta dr d theta. Okay, so I see that I need the derivative of r with respect to theta, so I'm just going to take that over here. So dr d theta is equal to 2 times cosine theta, and then later it looks like I'm going to be evaluating a lot of cosines and sines at pi over 6. So the cosine of pi over 6 and the sine of pi over 6 are equal to pi over 6. That gives me a height of 1/2 and an x of root 3 over 2. So sine of pi over 6 is 1/2 and cosine pi over 6 is root 3 over 2. Okay, we're going to save those for later. So now we're just going to substitute these in. Dy dx is equal to, all right, R is my equation. So 3 plus 2 cosine theta. And then times the cosine theta that's already there, plus sine theta, and then dy dx, or dr d theta is 2 cosine theta. Oops, wrong color. Okay. So we get dr d theta is times 2 cosine theta over negative r, so negative 3 plus 2 cosine theta times sine theta plus cosine theta times 2 cosine theta. All right. Okay, so that is the derivative of dy dx, or our polar equation dy dx. Now I want to take dy dx and evaluate it at theta is equal to pi over 6. So I have 3 plus 2 times the cosine of, why did I write cosine? It's sine. Wow. Look, right here, it's sine. So this is sine theta. So I have 3 plus 2 sine pi over 6 times the cosine of pi over 6 plus the sine of pi over 6 times 2 times the cosine of pi over 6, all over negative 3, and I'm going to distribute the negative. So minus 2 times the sine of pi over 6 times sine of pi over 6 plus cosine of pi over 6 times 2 times the cosine of pi over 6. Okay, next, time to evaluate this business. So I get 3 plus 2, pi over 6 is 1/2 times 1/2 times root 3 over 2 plus 1/2 times 2 times root 3 over 2, all over negative 3 minus 2 times 1/2 times 1/2 plus cosine pi over 6 is root 3 over 2 times 2 times another root 3 over 2. Okay, this simplifies to 2 root 3 plus root 3 over 2, all over negative 2 plus 3/2, which gives me, if I get a common denominator here, I need to multiply by 2. So 4 plus 1 is 5 root 3 over 2 over negative 1/2, multiplied by the reciprocal to give me negative 5 root 3. Serious algebra. Okay, so the derivative at pi over 6 evaluates to negative 5 root 3. Next, we're going to look at horizontal tangent lines of a polar equation. So to figure out a horizontal tangent line, basically is like what we did with parametric equations and vectors. We're going to look at if I have a number over, so since if dy d theta is equal to 0, that would be 0 over a number, which is going to give me a horizontal tangent line, a slope of 0. Okay. If I have dx d theta over equals 0, then I have a number over 0, which is going to give me an undefined slope or a vertical tangent line. So we need to start by looking at, find the point at which the graph of r is equal to sine theta, where 0 is less than or equal to theta, which is less than pi, and has a horizontal, and has a horizontal and vertical tangent line. I said that weird. I wrote that weird. Okay, what we're doing is finding the points where the equation has a horizontal and vertical tangent line. Okay, so I'm going to start with r is equal to the sine of theta. I know I need dr d theta, so that is cosine of theta. Okay, we're going to hold that for later. All right, let's say you can't remember how to do you don't remember the equation for the derivative. What I can do is write my equation parametrically. So I know that x in a polar equation is equal to r times the cosine of theta, and y is equal to r sine theta. So if I want to write my equation as a parametric equation, I just need to replace r with sine theta. So I get x is equal to sine theta cosine theta, and y would equal to sine theta squared, sine squared theta. Okay, so now I can take the derivative of each of these with respect to I can just take the derivative of each of these. Okay, so I'm going to do dy dx d theta is equal to, we have to apply the product rule. So the left sine theta times cosine, the derivative of cosine theta is negative sine theta. So times negative sine theta, okay? Plus right is cosine theta times the derivative of the left, which is the derivative of sine is cosine theta. So dx d theta is equal to negative sine squared theta plus cosine squared theta. Okay, dy d theta is equal to, I'm going to apply the chain rule here. So I have, this is sine theta all squared. So this is 2 sine theta to the first power times the derivative of sine theta is cosine theta. So 2 sine theta cosine theta. Okay, so I was able to get dy d theta without by writing my equation parametrically and then taking the derivative. I'm going to show you now using the rule. Okay, so let's say you have this rule memorized, dy d theta over dx d theta. I remember that the formula for the derivative of a polar equation is r times the cosine of theta plus sine theta times dr d theta all over negative r sine theta plus cosine theta dr d theta. Okay, so just going to go ahead and start filling this in. R is equal to sine theta, so I get sine theta times cosine theta plus sine theta. Dr d theta we decided was cosine theta times cosine theta all over negative sine times sine theta plus cosine theta times cosine theta. Okay, so I'm just going to clean this up a little bit. Sine theta cosine theta plus sine theta cosine theta is 2 sine theta cosine theta all over, this looks like cosine squared theta minus sine squared theta. And what do you know? My dy d theta, 2 cosine theta, is the same as dy d theta. And cosine squared theta minus sine squared theta is the same as dx d theta. So it doesn't matter how you derive the derivative. You can do it either way by writing the parametric equation the pink way, writing the parametric equation, then taking the derivative, or the blue way, memorizing the derivative, and then just picking apart the numerator and the denominator. Okay, so on to the good part of the question is, where are the horizontal and the vertical tangent lines? Okay, so I know that I'm going to have a vertical tangent line when vertical tangent when the denominator is equal to 0. So when I have a number divided by 0. So that means when dx d theta is equal to 0. And dx d theta is equal to, I can either look at my rule here, or I can look at the pink one here. Okay, so dx d theta is equal to cosine squared theta minus sine squared theta. And I remember from pre-calc that cosine squared theta minus sine squared theta is a double angle formula. That is equal to the cosine of 2 theta. This is going to make it a lot easier for us to solve. So I'm going to take the cosine inverse to get theta by itself. So the cosine inverse of 0, which is a ratio of sides, remember, okay, is equal to 2 theta. So when is the ratio equal to 0, the cosine ratio equal to 0? It's when I have pi over 2 or 3 pi over 2. So I'm going to put plus pi n because it's every 100 and so this is the one time in a cosine ratio, or the, well, 2 times it can happen. No, 1 time where the cosine ratio gives us an angle that is exactly 180 degrees apart. Okay, so you have pi over 2 plus pi n, and then to get theta by itself, we're going to divide by 2. Don't forget to divide into both terms. So I get pi over 4 plus pi over 2 times n is equal to theta. So when theta is equal to pi over 4, and remember we're in the domain of 0 included to pi excluded. Okay, so I have pi over 4, and we're going to add 2 pi, or pi over 2, sorry, to give me 3 pi over 4. If I add another, it'll give me 5 pi over 4, which is too much, so we can't, so that's outside of our domain. Okay, so it asks for the last thing for the vertical tangents is it asks for the points where we have vertical tangents. So the points would be, remember our equation from the very beginning is r is equal to sine theta. So I'm going to substitute in, to find the radius, I'm just going to substitute in pi over 4 in for r, and I'm going to substitute 3 pi over 4 in for r, or in for theta, excuse me. So sine of pi over 4 and the sine of 3 pi over 4. The sine of pi over 4 is root 2 over 2, and the sine of 3 pi over 4 is root 2 over 2, because these are 45-degree angles in the first and the second quadrant, so root 2 over 2. So the points where we have a vertical tangent are root 2 over 2, comma pi over 4, and root 2 over 2, comma 3 pi over 4. Okay, same process for the horizontal tangents, but this time we're going to set dy d theta equal to 0. Okay, so we have dy d theta is equal, this is horizontal. Horizontal tangents are 0 over some number, so that's why we have dy d theta is equal to 0. Okay, and from above we know that dy d theta is equal to 2 sine theta cosine theta, or from the rule, the numerator is 2 sine theta cosine theta. So 2 sine theta times cosine theta, and I remember from pre-calc that 2 sine theta cosine theta is equal to, is a double angle. that equals sine of 2 theta. So inverse sine of 0 is equal to 2 theta. And remember, the 0 is a ratio of sides. So when is the sine ratio 0? It's when we have a y coordinate of 0. So 0 and pi. Okay. So sine inverse of 0 is 0 plus pi n, because the angles happen 180 degrees apart. The angles that give me a ratio of 0 happen 180 degrees away from each other. Okay, divide by 2. I get 0 plus pi over 2n is equal to theta. So theta is equal to 0, and then add pi over 2, add another pi over 2, but that gives me pi, which is outside of my domain. So the points are, remember, r is equal to sine theta, so we need to evaluate r of 0, so sine of 0, to give me 0, and r of pi over 2, just sine of pi over 2, which is also equal to 0. So the points where we have a horizontal tangent are at 0, 0, and this is r and theta, and 0, pi over 2. All right, last one. Okay, this whole box tells us that when we're looking for a tangent line at a pole, the pole is the center of the polar grid. So when r is equal to 0, okay? So we don't know what angles would give us an r equal to 0. What we can do is we take our equation and we're going to just set that equal to 0. Okay, so we have r is equal to 4 times the sine of 3 theta. Okay, and we're going to find the tangent lines when theta is between 0 included and pi excluded. Okay, so we're just going to find the coordinating angles that go with our radius of 0, basically. Okay, here we go. So we have 4 sine theta is equal, 4 sine 3 theta is equal to 0. Divide by 4. 0 is equal to sine of 3 theta. Inverse sine of 0 is equal to 3 theta. Again, this is your ratio. So side lengths. Sine has a ratio of 0, just like the last problem, at 0. Remember, at 0 and at pi. So we can write this as 0 plus pi n is equal to 3 theta. Divide by 3. I get theta is equal to 0 plus pi over 3n. So that means that my angles would be 0, pi over 3, 2 pi over 3, and then pi is out of our domain, so we don't write that one. Okay, and I asked for the equation of the tangent line. So this cool thing happens in polar equations. Remember from yesterday that we had theta is equal to pi over 6, and really when I graph that in, that's just the equation of a line, like a line that goes through 0, 0. So when I get my angle measurements for the tangent lines at the pole, when I solve for the angles and write theta is equal to 0, that is the equation of the tangent line in polar form. So separately, we can write them as theta is equal to 0, theta is equal to pi over 3, and 2 pi, and theta is equal to 2 pi over 3. And these would be our equations of our tangent lines at the pole. That's it. Okay.